Students performed an experiment to test the conservation of mechanical energy of a vertical block spring system as shown in the figure. The position x equals 0 is the point where the block of mass m hangs at equilibrium. The weight of the block and the stretch of the spring to this equilibrium position are used to determine the values of the spring constant K. The block is pulled down and released from rest. A motion sensor collects data for the position x and the velocity v of the block. These data are used to create the graph of potential energy of the spring block system, kinetic energy K of the block, and total energy E of the spring block system as functions of x shown. Which of the following is the most likely source of error to describe the variance in the total energy of the block spring system indicated in the graph? Notice please that the discrepancy is in the fact that mechanical energy is apparently not constant, but it shows a minimum value at the equilibrium position and higher values at the lowest and highest points of the trajectory. Because of conservation of energy, we are inclined to suppose that whatever energy is not taken into account has a maximum at the equilibrium position. In particular, as the object passes the equilibrium position, it has a maximum velocity, and the different coils of the spring are moving with the highest possible speed. This implies some kinetic energy being absorbed by the spring. The fact that the graph is symmetrical for the highest and lowest points of the trajectory indicates that, indeed, this discrepancy only occurs when the spring is in motion. Therefore, the most likely answer is option C.